Okay, we're analyzing motion along a horizontal line. So in this question, though I haven't written it in words, they tell us that some object is on a horizontal line, which we know that's going to mean deals with left and right. Okay. And the object's motion is modeled by this function here, s at t. So that's its motion along a straight line, so we know it's horizontal. And its displacement from its starting point is modeled by this in terms of time. Time is only between 0 and 12 seconds. This parameter is very important. If you remember in the other one, we couldn't have anything less than 0. That helped us out with solving one of the questions. Okay, so we're only talking about time between 0 and 12 seconds. S is in meters, so displacement in meters in terms of seconds. They've also told you when you're discussing, so you're kind of making up your own question because they're asking you to discuss this. They want you to include initial and final velocity and some form of acceleration. Okay? So let's try to make sense of this. First things first, let's find out its initial and final position. Those are probably important. We like to know where we start and where we end. Okay? So position is the original equation. So we're just going to call this part A of it. The original equation is s at t is equal to t squared minus 10t. Initial position will be at t when it equals what? 0. And what will the final position be? T equal to what? 12. Yes, the number I pretty much just wrote before. Okay? And that's because time only exists in this question between 0 and 12. So starting and ending point. So we'll plug those in quickly. We find s at 0. S at 0 is going to be 0 squared minus 10 times 0. Well, that's 0. So it starts at its starting point. That makes perfect sense. And then s at 12 gives us 12 squared minus 10 times 12, which gives us 144 subtract 120, gives us 24. Okay? So we know it's been displaced 24 from its original spot. We don't really know where, but whether it's left and right, we'll have to figure that out. Okay? Now, velocity is going to help us in determining left and right. One of the important parts of velocity is we probably want to figure out where the resting points of velocity are. Because we know at the starting point, it's where it starts. So let's try to make an idea of this. We'll make a little graph here. Or line. Sorry, number line-ish. Okay, we start at our starting point, 0 from it. At some point, we're 24 units away. Now, whether we go to the left to start, then come back right, and then come back a little left and end at 24, who really knows? But what's going to really help us is its turning points, if there are any.
And Alicia Ramador, please come down to the main office. Alicia Ramador.
So, maybe it has a starting point and it goes directly to 24. Maybe it goes to the right, comes back left. Maybe it goes to the left and goes to the right. Those turning points will give us an idea of when it's moving left and when it's moving right. So, in order to find the turning points, we're talking about when tangent lines are horizontal, which means 0. So we got to find a derivative of this. So our velocity, or in other words, our s prime t, is, and this question was t squared. So when we derive this, we're going to get 2t minus 10. So our velocity is measured by this equation. We need to figure out what turning points it has, if any. Well, in this question, that's when velocity is 0. So when velocity is 0, we plug that in. 0 is equal to 2t minus 10. We bring 10 over. 10 is equal to 2t. Its only turning point is at 5 seconds, which is good because 5 seconds is between 0 and 12. So we know we start somewhere, and we got to figure out, we know it's at 5 seconds, that's our 0 point, okay? We have to figure out, though, if it starts by going to the left for 5 seconds and then goes right, right? Because we only have two options. It only turns once. So it either goes to the left for 5 seconds and then turns off right and goes there forever, or it goes to the right for 5 seconds and then turns off left and goes that way forever. We're going to need to figure that out in terms of its motion. So what we're going to do is we're going to find a value in between. Okay, now there's two ways we can do this. We can do it like we did in the other question. We need to find out when velocity is greater than 0. Sorry, not equal, but greater than 0. And when velocity is greater than 0, that'll tell us we're heading what direction? Positive means what on a horizontal line? To the right, okay? And we'll also want to figure out when velocity is then less than 0. So we can try to solve it like a question like that. Or we do know that between 0 and 5, it's heading one direction. And then again, from 5 to 12, it's heading another. We can plug in an arbitrary value in between there and find out if velocity is positive or negative. Either of these will help us solve this question because we know the only turning point is at 5. Okay? So let's just do one way and the other. So our velocity question, we know velocity needs to be greater than 0. So 2t minus 10. Okay? When we bring 10 over, we get 10 greater than 2t. And divide by, oh, that gives us our 5. T will be greater than 5. Okay? Oh, so that's perfect. We needed, sorry, that's exactly what I wanted. T is greater than 5. What that just figured out is when we're greater than 0, so greater than 0 means positive. Okay? So greater than 0 is positive. When velocity is greater than 0, we're headed in a positive direction. In other words, we're headed to the right. And it's when t is greater than 5. So in other words, after 5 seconds, it's heading to the right. Okay? So that's after 5 seconds, which means before 5 seconds, between 0 and 5, we're headed to the left. And we can double check that by taking an arbitrary value. Let's just take at 2 seconds. Okay? Remember velocity was this question 2t minus 10? Well, let's find out velocity at 2 seconds. Well, that gives us 2 by 2 minus 10, which gives us negative 6. Perfect. Velocity is negative. That means we were moving to the left. That's exactly what we had found. So in terms of finding out about this question, here's our line. We started at our starting point. Actually, I'm going to say our starting point's here because we need to encompass left also. It goes to the left. At 5 seconds, there's no velocity. In other words, it turns around and then it heads to the right. Okay? So after 5 seconds, we're going right. And before 5 seconds, we're heading left. Okay? They also asked us to find initial velocity and final velocity. Well, initial velocity will be when t is 0. And final velocity will be when t is 12. So we take our velocity question or equation. V at 0 gives us 2 times 0 minus 10. And V at 12 gives us 2 times 12 minus 10. Velocity in the first one is negative 10 at 0 seconds. So that velocity meters per second, okay, it's heading 10 meters a second to the left. At 12 seconds, our velocity, 24 minus 10, is positive 14. So it's heading 14 meters a second to the right. Okay? So we found initial, final velocity, starting point 0, ending point 24 meters away. And what we do, sorry, here's our ending point. We know that's going to be 24 from 0. And we should find out our acceleration. Okay, now they said any form of acceleration, so acceleration at any time. So maybe we can find out the acceleration when it starts and its acceleration when it ends. Okay, that might be a good idea. We could even find out acceleration at its turning point. These are all important points in terms of the motion of this object. So first of all, in order to find acceleration, we need to find our second derivative. Okay? That's not supposed to be negative, it's supposed to be positive. So, in order to find acceleration, we have to derive our velocity. So acceleration, which is equal to our derivative of velocity, or the second derivative of our original equation, is equal to what in this question? When I derive that, what do I get? 2. Well, there's no equation there. So what is the acceleration throughout the entire question? It is 2 meters per second squared throughout the entire question. This means that our acceleration is not changing because it's not a function of time. There's no variable involved here. So we're at 2 meters per second acceleration throughout the entire question. So that's described quite a bit of the motion of this thing.